Welcome to qnawire.
So over here we're going to have the following compound, and let's notice that the ligands are going to be pointing down of the plane, and up of the plane for each of the substituents that we have. So the first step that we need to do is to label the carbon atoms that we're going to have in our cycle. So 1, 2, 3, 4, and 5. Next thing, what we're going to do is do the same thing with our shared conformations. This is going to be 1, 2, 3, 4, and 5. And when we do the ring flip or ring inversion, what we're going to get is that the number shifts by one position. Okay? So in this case, I'm just going to take out this ring inversion because we're going to employ that space. And remember that we're going to have equatorial and axial positions. So axial positions and equatorial positions can have an up and down configuration. In this case, on carbon 1, looking down is going to be our first ligand in an equatorial down position. Let me erase over here the equilibrium line just to have a space for the ligand. Well, for the substituent, and the substituent is the following. This guy that looks like a chicken leg. CH3, CH3, CH3. Next up, we're going to have on carbon 4 and a looking up position. This is going to have an equatorial up position, a chlorine atom. And on carbon 5, we're going to have a CH3 that is going to be in an equatorial looking down position. So over here, H3C. Remember that this is equatorial looking down, this is equatorial looking up, and this is going to be equatorial looking down. So all of the substituents in this case are going to be in equatorial positions. Now, upon the chair flip, we're going to do the same exercise, but now what is going to happen is that on carbon 1, my substituent now is going to be on axial looking down position. Okay. Now on carbon 4, the chlorine atom is looking down. Sorry, the chlorine atom is looking up, as we had initially. So the chlorine is going to be in an axial looking up position. And finally, on carbon 5, we're going to have the CH3 looking down. So this is going to be, I'm going to exaggerate the distance over here just to emphasize that this is an actual looking down position. We're going to have our CH3. So this is going to be our configuration. If you want, you can make the bond way smaller. So in this case, it would be directly over here, the CH3, if you want. So those are both of the conformations that we're going to have. Remember that this is an equilibrium through a ring flip or ring inversion. In this case, the one that is going to be favored is going to be the one on the left because it has most of the substituents in equatorial positions, and you're going to avoid the 1,3 axial interaction present in cyclohexane rings. So that would be all. Thank you very much and have a good one.